Hello everyone, my name is Aaryan and I'll be talking about experimental methods for lightning resistant material. So this study as such will look at different methods for incorporating graphene thin films into carbon fiber reinforced plastics, and then we'll try and assess the electrical conductivity through methods such as the fabrication of highly conductive functionalized nano-sized graphene thin films and combined use of carbon nanotubes and graphene nanoplates. The mentor for the program was Professor Dr. A.K.M. Rahman, and the lab was done at the Computers and Biomaterials Lab at City Tech. So, lightning strike protection has recently been a newly developing field, particularly with the emergence of graphene thin film integration into carbon fiber composite structures. So, this technology has widespread applications in airplanes, wind turbines, and other instruments which are largely susceptible to frequent lightning strikes. So in this particular study, we are going to develop GTFs using GNP impregnated polymers. So electrospinning processes will be used to develop this GTF. The study will include the investigation of large area shear crack and warpage on the graphene films. So successful development of a highly conductive blends could result in an increased safety standard for aircrafts and reduced maintenance costs for wind turbines and increased use overall of wind energy. The materials we have largely used are composite laminates and a variety of coatings using pristine graphene. In our method to fabricate these panels, flexible GTFs made of pristine graphene were used using a process involving mechanical mixing, sonication, filtration, compression, and removal. An energy output of 50 watts was applied to the test side of the energy and was measured using an open hole measurement of the reception side with the test panel. The difference between the open hole reference and the test panel was considered as the shielding effectiveness of the material. So the two images illustrates the 3D view of the damaged volume observed from two different angles after a simulated lightning strike. And this was obtained using electrosonic testing. So the color scales on the right hand side represents the thickness readings taken from the damage zone. So the image on the left shows the control panel and the image on the right shows the pristine graphene. Here is a secondary bit of analysis. The pictures here show the damaged areas by the simulated lightning strikes. So the control on the left has significantly more damaged area on the ultrasonic testing. The pristine graphene, on the other hand, has significantly lower area damaged. So what does this mean? So from the data, we can clearly see that graphene in any form reduces the resistivity of the medium. Likewise, a larger depth of graphene also showed a reduced resistivity, although there was an optimum region somewhere in between. Readings higher than that always resulted in higher resistivity, meaning that conductive pathway seems to be hindered in some form. Another evaluation which we could draw was that pristine graphene clearly showed conductive pathways and reduced the volumetric damage to the material underneath the film. So these properties examined would mean that vital progress could be made to the aviation industry and large-scale wind turbines. So here is the poster. Feel free to pause and take a look at our complete results. The full poster can be found on the CUNY Academic Works website. Thank you for your time and have a nice day.